All right, everyone. Um, yeah, thanks for joining the Fluid Life webinar. My name is Mark Pinkerton. I'm a senior account manager here at Fluid Life. Uh, the majority of the customers I support are in British Columbia, Alberta, Ontario, and Quebec, and I focus mostly on mining and construction equipment, but do have a little bit of experience in plant equipment and generators and stuff like that as well. So today's webinar is about diesel fuel, quality and cleanliness. If you're familiar with the basic concepts of diesel fuel quality and cleanliness targets and all that kind of stuff, there may not be too much new shared today. It may just be a refresher. So this is pretty basic concepts, but just so everyone knows, this is a consolidated version of a webinar that already exists on our website that goes into a bunch more detail about specific fuel characteristics, contamination prevention strategies, and stuff like that. I believe it's about an hour or two long. Today, we just wanted to shorten it up and talk about the main concepts. But after this, if you're interested in learning more, just know that there is a more detailed version on our website, along with webinars on other topics, data interpretation in terms of oil analysis on different component types. And there's a newer one on that's specific to varnish and acidic byproducts from oil degradation and stuff like that too. But so today, um, we're going to focus on diesel fuel. So first of all, what is diesel fuel? So we'll talk about diesel fuel uh, in general basic terminology here. So I think, even if you are not a diesel fuel expert or a tribology expert or anything like that, most people know that diesel fuel is basically the power source of an engine. It gets combusted, and that's what essentially drives the engine and provides movement and power and all that kind of stuff, right? What may be less known is that on top of being the energy source, the fuel source, diesel fuel also acts as a coolant and a lubricant for fuel systems. So it's pulling heat away from metal surfaces that experience friction from high pressure and flow and movement and stuff like that. And it's also providing lubrication to the moving parts in your fuel system components too. So it's not just a power source. It flows around, it provides lubrication, it takes away heat. So it does need to be contaminant free, whether it be liquid contaminants or solid particulate or whatever, for it to effectively do everything it's supposed to do inside your diesel engines. There's such thing as diesel fuel grades, and this is categorized based on a fuel's viscosity, so its resistance to flow or how thick it is an easier explanation, and also its pour point, so at what temperature it actually starts to flow and move. The two most common grades would be the 1D and 2D. The 1D, we'll get into a bit more detail here. It's typically used in colder weather. So think of like a kerosene versus a 2D would be your more standard diesel fuel for the summer months, or if you are in more tropic areas or warmer climates, it might just be the diesel fuel that's used all year round. Um, there is a grade called the 4D, which exists out there. Obviously, it's typically used in lower speed engines. But if we're going to talk about typical, normal diesel fuel engines like we are today, it's not really considered that much. Where do diesel fuels come from? What are the types of diesel fuels? Obviously there's the traditional distillate. So this just comes from the distillation of crude oil. Distillate of crude oil at certain temperature ranges will create different layers, which gives us different petroleum products, everywhere from lubricating oils to fuels to paraffin to gasoline, etc. There's also biodiesel fuel, which is created through the conversion of feedstock. So it can be different types of oils, animal fats, etc. Again, we won't get into too much detail, but basically you take these feedstocks and it goes through a process of transesterification, which results in the production of ethyls and esters. And if you've ever seen the abbreviation FAME or FAME, that's basically the name, these fatty acid methyl esters that's given to the byproduct of the transesterification process, which basically creates biodiesel fuels. Now we can have different blends as well. So the most common one being winter versus summer diesel fuels. The reason that different blends exist is to be able to use diesel fuel effectively in different temperature ranges. So a summer blend is going to primarily be #2 diesel, if not a full pure formulation of #2 diesel. And you can typically use these diesel fuel blends without any problems up to, around -7 Celsius. I'd say that's a maximum. As soon as you start getting into the -Celsius temperature ranges, you may start to see some of the negative effects correlated with that diesel fuel formulation. Winter diesel, on the other hand, usually a blend of #1 and #2. #1 grade diesel, again, I mentioned kerosene there, is going to be higher in terms of concentration in the blend. And the main goal there is to lower the cloud point, so anything below 7 Celsius without experiencing any of that clouding or wax formation and stuff like that. But we'll get into that in a bit more detail here as we go along. There exists blending between traditional distillate fuels or diesel and biodiesel. So if you've ever seen a B value or a BX value, all that means is it represents the total concentration in percentage of biodiesel fuel in your diesel fuel blend. So the most common ones here, like a B5, super common. Basically, it behaves the same way as 100% distillate fuel would. And then on the other extreme, you can have B100, which is 100% biodiesel, and there's no distillate diesel in there at all. Some advantages and disadvantages, 100% biodiesel compared to B5 or 100% distillate. Obviously, you're going to have a reduction and elimination of burned hydrocarbons, reduced carbon monoxide emissions. You're also going to have a reduction in the particulate matter that's included in the emissions from distillate fuels. Other than that, though, biodiesels have a higher natural fuel lubricity, so it improves the lubrication of your fuel system components by reducing friction more effectively than typical distillate fuels, and it also has a natural lower sulfur content. So good stuff about using biodiesel fuels. The disadvantages you should be aware of. Typically, it has less stored energy, so you're probably going to get less fuel economy in 100% biodiesel blends. It's more susceptible to fuel degradation and formation of degradation byproducts. It might be a bit more prone to filter clogging from weaker cloud points and the formation of these byproduct materials. And I guess to finish, it also has a higher potential for microbial growth due to its ability to absorb and dissolve more water. So again, we'll get into these things in a bit more detail, but just as an intro into diesel fuels, just take note of that. It's pretty important stuff. Other forms of diesel fuel that we won't get into pretty much at all today, just to be aware that they're out there. Some of the options that you see on your screen here, the advantages and disadvantages that we talked about. There are better and worse options depending on what kind of engines you're running or what environment you're working in. Some of these engines have super high stored energy. Some are very efficient in terms of combustion. Some require your engines to be modified and stuff like that. So just be aware that there are different diesel fuel types out there as opposed to just the standard distillate and biodiesel options. Okay, all diesel fuels have characteristics. Here's a bunch of them. In the full webinar on our website, I go into detail about all of these characteristics, what they actually mean, how they're measured, OEM standards, that kind of stuff. I guess the most important to take away from today is that there are quality standards tied to diesel fuel, and the universal standard specification for diesel fuel is typically known as the ASTM D975. It covers the requirements for 7 grades of diesel fuel, including, the 3 main ones that we see up here. It's going to give you fuel quality and cleanliness guidelines, cetane numbers, sulfur content, flash point, all that kind of stuff. And engine manufacturers will typically have their own specifications based on this actual ASTM D975 guideline. So, Caterpillar has some, Cummins has some, Komatsu has some. And if you're interested in OEM-specific diesel fuel guidelines, we do have some information that I can share with you following up via email or however you want to communicate. So that's the brief little introduction to diesel fuel. And now I'll actually focus on cleanliness and contamination. So why is diesel fuel cleanliness important and preventing contamination? It's the same as, if you know of Fluid Life, we're primarily an oil analysis lab in terms of lab services. So it's the same idea, right? Today's engines have higher pressures, smaller clearances. And again, your fuel is not just the energy source, it's also a lubricant and a heat dissipator. So it needs to work well as it's flowing through your engine, right? The majority of diesel engine failures related to the fuel have to do with contamination. So it's very little has anything to do with combustion efficiency or stuff like that, or sulfur content or whatever. It's more so to do with the actual contamination levels of the diesel fuel. So the ones that we're going to focus on today have to do with water, solid particulate, fuel degradation, oxidation, filter clogging, and carbon deposits. So water, we'd love for diesel fuel to be completely dry, quote unquote, but similar to oils, the reality of real world working environments is chances are there's going to be some concentration of water in your diesel fuel. But it all depends how much is actually in there. You can have 3 different phases of water contamination in your diesel fuel. The first one is called dissolved, and this is when there are actual water molecules that are held in solution in the diesel fuel, right? So they're not separated from the fuel itself. It's being held, and essentially, the warmer your diesel fuel is, the more quote unquote dissolved water it can hold. And the higher the biodiesel content in your fuel, the more water it can hold as well. As the concentration of water increases and the level of water contamination increases, you're going to get close to the saturation point. And that's when we get into the emulsified / free and dispersed phases of water contamination in diesel fuel. So the emulsified stage is when the saturation point is reached and you're starting to get small little water droplets that still remain suspended in the fuel. So again, they're not completely high enough concentration where you might see distinct layering at the bottom of a diesel tank or something like that, but it's getting to the point now where water is starting to accumulate and create these little droplets that still remain in suspension. But at this point, your diesel fuel might just start look cloudy. And then finally, free and dispersed, where the level of water contamination continues And now it's at high enough concentration where these droplets get big enough where now density starts to come into play between water and diesel fuel, and they'll actually settle at the bottom of a bulk tank or a fuel tank on a piece of equipment or whatever. So most OEMs and the ASTM D9975 guideline is to have no more than 500 parts per million of water, or 0.05%. And that's typically the point where you'd start to transition into the emulsified stage. Okay, sources of water, whether it be in bulk tanks or in your actual equipment or coming from fuel deliveries. I mean, it's a lot of common sense here. You know, your fuel can already be wet when it's delivered on site. Condensation in tanks is a big one. So tank breathing, you know, as fuel is consumed or pumped out, it's replaced by air. Is that air humid? Tank contamination, so actual liquid water getting into your tank. So not necessarily just humidity, but you know, is there any sources that rainwater can get in? If you power wash your tanks, is some of that water getting in as well on the inside, right? So again, not crazy concepts, just a lot of common sense. And then handling and dispensing errors, you know, what is the quality or the health of my vents, fill ports, seals? Pretty much just think about any tank, whether it be on equipment or bulk tank, and consider the entry sources of water or solid particulate or anything like that. And that's basically what you have to focus on for this. Water damage in the engines. So what is diesel fuel saturated with water going to do when it's in your actual equipment? It's going to have the largest effects when it's in that emulsified and free and dispersed state. You're going to have to worry about three main things, right? Corrosion, reduced lubrication, and then also what free water does while it's flowing through your fuel system. So corrosion, you know, the water is going to combine naturally with acids present in the fuel, and it's basically going to promote corrosion of your fuel system parts. You know, it can create rust, can lead to component seizure or moving part seizure. I know injectors can fail quickly too from rapid corrosion, so that's one of the main things you have to worry about. Other than that, reduced lubrication. So we talked about fuel being a lubricant to your fuel system components. At high enough concentrations, water can break down the protective film strength of the fuel and lead to increased metal-to-metal contact, especially for low clearance parts. And this might lead to something called abrasion wear. And then lastly, free water in the system. The three main wear modes: pitting, which is caused by free water flashing off on hot metal surfaces; cavitation, you know, vapor bubbles from free water evaporation implode, subjected to sudden extreme pressures that's going to impact the health of metal surfaces; and then spalling. This one I had to learn about myself a little bit. I wasn't familiar with this, but it's when free water is forced into microscopic cracks present in metal surfaces. And these high pressures cause water to separate at a molecular level and release hydrogen in small explosions. So yeah, it's not just a reduce in lubrication and potential corrosion. The water molecules, while flowing through, you know, they can explode, they can evaporate, a whole bunch of stuff, which is going to promote wear in your fuel system components too. So some visual representations of what this looks like. We got some injector needles here, nozzles and seats. And you can see examples of corrosion and pitting and stuff like that. So if you've ever, you know, looked at a failed component, or you've done midlife injector changeouts, and this is what it looks like, it probably has something to do with water in your diesel fuel. Okay, what kind of damage is water going to do when it's in your storage tanks? The biggest one is going to be microbial growth, right? So bacteria, fungi, and other microbes live in water, and they use diesel as their primary food source. Once they start to grow and feed, they're going to turn into particulate. In some cases, they can just be solid particulate, in other cases, more semi-fluid. But the biggest danger is they're going to clog your filters and damage your fuel system components if they actually make it into the equipment. Biodiesels are more susceptible to this type of stuff just because of their ability to hold more water. And if you look in the top right-hand corner here, if you have this problem and you start seeing like dark brown or black or dark green, slimy sludge build up on your fuel filters, that's typically an indication that you have some type of issue with microbial growth. Other potential issues, rust and corrosion. So if you have free water and it's touching steel or metal, it's probably going to create some rust. Free water in your bulk tanks will also eventually react with fuel additives. They'll pull them out of the hydrocarbon chains. And depending on the nature of the additive, some can precipitate out, others might turn into sludge and deposit in your fuel tank and stuff like that. And then finally, fuel oxidation. So if you're familiar with oil degradation, oxidation, the natural process, pretty much the exact same thing can happen with diesel fuels. So again, water just naturally accelerates and promotes that oxidation reaction with hydrocarbon petroleum products. So that's something to keep in mind too. It's not just unique to oil analysis. It's also with diesel fuel as well. Okay, solids and particulate contamination. So again, today's engines have higher pressures, lower clearances. Say on average, we're running about 30,000 PSI for the injection systems, and they are designed with clearances to about 2 to 5 microns. Most OEMs will design fuel filtration, for particles to work below the 4 micron category. So very, very small particulate here. So how is particulate going to damage your system? So again, these are high pressure, high flow systems. If you have little grains of sand or metallic debris or whatever the case is, it's eventually just going to erode down, develop flow lines, and can eventually lead to fuel leakages. It can puncture and attack the softer surfaces in your fuel system components, so seals, injector seats, and stuff like that. And then also the injectors themselves, think of the clearance sizes as in one of those things, particularly like the needle or nozzle. You're basically just going to chip away at those, and it can affect spray pattern and combustion efficiency and all that kind of stuff. So again, you want your diesel fuel not only to be dry, but also to be clean. Potential sources of solid particulate contamination. Same principles, same basic concepts as water, right? Is my fuel clean when it's delivered on site? Do I have any corrosion in my tanks creating rust? Do I have any microbial growth? Am I getting any solid contamination from the exterior? Are my fuel system or my fuel distribution components breaking down, fuel lines, pumps, seals, gaskets, even filter housing, stuff like that? And then handling and dispensing. What are our fuel handling practices? Is there ever a moment in time in the distribution network where it's open to the atmosphere or not filtered properly and stuff like that? So very similar sources as water. So water and contamination or solid contamination, when you're looking to improve things, you're basically considering the same potential sources. Okay, similar to that 500 parts per million water threshold in terms of allowable water content or maximum water content, OEMs and that ASTM D975 guideline, they also have a maximum cleanliness rating. So for this, you'd have to be familiar with ISO codes, but 18, 16, 13 is pretty much the maximum And that is what we start flagging cleanliness at, and that's what the majority of your OEMs would give you in terms of maximum fuel cleanliness, maximum being the dirtiest allowable fuel. Fuel oxidation. So like I mentioned, just like lubricants, diesel fuels can oxidize when they're exposed to high temperatures and contaminants for long periods of time, or they can be in storage for too long, etc. When a fuel is degraded through oxidation, it's more prone to create oxidation byproducts, so gums, resins, deposits. And I think the most important thing to keep in mind is these byproducts do not burn with the fuel during combustion. They will instead deposit and coat the inside of your fuel lines, pumps, injectors. They might clog filters prematurely, etc. Right? So again, oxidation, degradation, not just an oil problem. It can also definitely happen with fuel. Visual representation of this, if your fuel is heavily oxidized to the point where it's going to start changing color, you can see in the bottom right-hand corner there, it'll just eventually start getting more and more brown, lead to a dark brown and black. Now, that doesn't necessarily mean the color is directly correlated with the amount of oxidation that's been occurring, but it can at least give you a visual cue that that's probably what's happening. Okay, some potential causes for fuel oxidation and degradation. Temperature is going to be a big one, right? So if any thermal stress is applied to a diesel fuel, it's going to actively accelerate the oxidation process. So the most common sources for this would be like, faulty fuel coolers or improperly sized fuel tanks, inadequate mixing of return fuel. So if you just have fuel that is unburnt through the injectors, but never gets back to the tank to cool down and is just circulating over and over again in the rail system there, that's a big one. And then also a lack of heat dissipation in fuel tanks. According to guidelines, OEMs recommend a maximum of 70 degrees Celsius at the fuel pump inlet, and oxidation reaction in diesel fuel will double with every increase of 10 Celsius. Again, biodiesels are more prone to this due to the decreased thermal stability naturally in biodiesels compared to distillate diesel blends. So take it a bit more seriously if you do have high B ratings. Water content, catalyzing metals, pretty standard stuff. Water, hydrogen, oxygen, going to promote the natural oxidation process. Catalyzing metals, specifically copper, if they're in your fuel for any reason, they act as a catalyst for the oxidation reaction. And then storage time, assuming temperature, contamination, stuff like that isn't an issue. Diesel fuel is going to react with oxygen naturally when it's in storage for a long period of time. General guidelines for how long a diesel fuel can stay in storage is going to be directly related to the concentration of biodiesel in your blends. So if you have a B5, pretty much around a year, it should be fine in terms of oxidation stability. If you have 100% biodiesel, you're probably looking at a 3-month maximum storage turnover. And all this stuff should definitely be specified by your fuel provider or distributor before you start putting it into your bulk tanks. Filter clogging, another potential issue. This one's a bit more straightforward. You clog your filters. You might encounter fuel starvation or erratic fuel delivery, stuff like that. Again, general OEM recommendations is not to have fuel pressure fall below 70 psi. Sources of filter clogging that may affect fuel pressure and delivery. Wax deposits is going to be a big one, and this is pretty prevalent when seasonal changeovers from diesel fuel blends occur. You can see we have the picture here, and to differentiate wax generation from microbial growth, is wax buildup on filters is it's more typically going to be white or light browns or beige or yellows, whereas microbial growth is going to be more dark black, dark green, dark brown, etc. So that's hopefully how you guys will be able to make the distinction if you're doing any filter inspections. Other than that, solids, particulates, is my oil so dirty that the filters are being consumed quicker than they should be? Do I have any additive dropout from water? Even biodiesel, right? The quality of transesterification. Are there any residuals from that feedstock that didn't get transformed to the ethyls? So all this stuff, pretty much anything that you can think of that would clog up your filters may be a potential source of fuel starvation. And the last one we'll talk about is engine carbon deposits. So obviously, if combustion was 100% effective all the time, we wouldn't have carbon residuals or deposits, but that's usually not the case. So what are the potential issues related to carbon deposits? Reduced airflow. So these deposits can alter airflow patterns in the combustion systems. Hotspots might develop, which can lead to localized overheating, and a reduction in engine efficiency can also lead to lean mixtures in terms of diesel fuel to air. Reduced fuel delivery, carbon deposits on injectors are going to also alter the fuel delivery in combustion chambers, spray patterns, and stuff like that. Again, causing lean mixtures. You can experience misfires, poor fuel economy, rougher idling, increased emissions, stuff like that. The most common source of engine carbon deposits is going to be low quality fuel. So low quality diesel fuels are more likely to have higher rates of incomplete combustion and are also typically saturated with unwanted contaminants. So the stuff in fuel that doesn't burn off and stays either in your engine oil or combustion chamber or whatever. And then also high idling frequencies. So usually idling periods of longer than 10 minutes are going to lower combustion chamber temperatures and increase the amount of incomplete combustion. Okay, moving on now to mitigation and contamination control. Contamination control strategies. So again, a lot of this stuff is common sense, or it's just following your OEM service manual recommendations, especially at the equipment level, right? So draining your tanks, making sure all the water that builds up there, the sediment gets drained out at some point. You may have to do it more or less than OEM recommendations, depending on the environment you work in or actual running hours, stuff like that. Fuel tank vents is a big one. So are my equipment tanks properly vented? Do they have good fuel caps? Tank breathers, do I have some type of vent filter on it or breather or whatever that's rated to 10 microns, which is directly correlated to most OEM recommendations on your actual equipment fuel tanks. Again, just consider the environment you're working in and stuff notes that might be on your work orders and PMs. So, most diesel engines, they should have at least some type of filtration system on them, whether it be single series or primary, secondary filtration with a water separator, right? But again, depending on your work environment, your running hours, you may or may not have to go above and beyond what your OEMs recommend. So questions to ask yourself, right? Are we changing filters more often than we should? If so, why? Are the water separators filling up early? Are OEM filtration recommendations in the service manual, are they even sufficient for the environment that you work in or your PM schedule or whatever? So just all stuff to keep in mind when you're considering fuel contamination mitigation strategies at the equipment level. Now, there's also a lot to think about outside of the actual equipment, so how are our fuels being stored? How are they being handled? What are all the transfer points or potential touch points within our distribution network, right? So things you want to consider, um, storage time. So how long is our diesel fuel actually going in there in correlation with our biodiesel content? What do we have in terms of tank breathing? Do we have desiccant breathers? Do we just have a random gooseneck with a metallic screen on it? And then also, what is the average fill level of our fuel tanks? If we have fixed roof bulk diesel tanks, are they more often full, or are they more often half full, or what is the typical volume? How much actual breathing and condensation can get in there? So just to give you guys a little bit of a visual aid, here is a super basic configuration of a diesel fuel bulk tank. So what you should have, a drain valve, which should hopefully be closest to the area where water and sediment is going to accumulate, so you can get out of there without pumping out too much fuel when it's full. A vent and air filter, so again, to prevent humidity and dirt and dust from entering when the tank actually breathes. A fill cap rated to at least 10 microns with some type of screen when the bulk tank is getting full. And then definitely some type of filter at the distribution nozzle just to give it that one last little clean. And then also make sure that your nozzle itself, whatever you're pumping the fuel into, is not open to the environment, not accumulating contamination at its tip and stuff like that too. So again, mostly common sense, but if you don't think about it, it can potentially cause some issues here. So in terms of optimization of storage and handling, filtration should be, a definite. It's always recommended to have some sort of filtration process between major transfer components or transfer points. One or two stage filtration, down to 4 microns is recommended, and also some type of water separator or coalescer to try and get the water content down as low as possible, but at least below that 500 parts per million maximum. Dispensing. So dispensing is another major point of potential contamination. So again, how clean is your fuel when it gets to the fuel islands or to the fuel distribution points? Do we have last stage filters before it actually comes out of the nozzle? Are the nozzles open to the atmosphere? Are they protected or whatever? So again, just stuff to consider. And the main things is keeping your ISO particle codes below 18, 16, 13, and that water content below 0.05. It's pretty much the most important thing in terms of diesel fuel contamination health. And then the last thing to think about would be seasonal transitions, if that is applied in your operations. So what are my tank levels when I start transitioning from summer to winter and winter to summer? Is it going to be a mix of the two? If it is, can my equipment handle that? At what point in the season are we starting the transition? What is the average temperatures during that month or week or whatever? And it's even more important when you're heading into the colder months. So your transition to summer to winter. Winter can function in summer months. You just get a little bit less fuel economy, but you're not going to have the same potential gelling and clouding issues as you would when you go from summer to winter. So diesel fuel monitoring. So good news is Fluid Life, yes, we are a tribology lab, which is primarily oil analysis, but we offer a whole bunch of diesel fuel analysis options as well. So the minimum testing requirements is something we've talked a lot about here. ISO particle counts, your ISO cleanliness codes, and your water. This would typically be basic testing packages that you perform on samples taken from actual equipment. Whereas contamination and storage, there's a bit more there in terms of microbial growth, distillation for potential diesel fuel mixing, bottom solids and water analysis for larger storage tanks. We have seasonal change packages, fuel specification packages. If you need to do any troubleshooting based on fuel above and beyond just contamination. So we do have testing packages and options for any potential fuel issues that you're having. Recommended testing locations, fuel delivery. As soon as you get a major shipment in, it's a good practice just to send in a sample to the lab, even if it's just for water and particulate analysis. Quarterly bulk tanks are good, especially with the transitions from summer to winter and winter to summer, just to see the cleanliness levels of your bulk tanks, the blends, all that kind of stuff. And then individual equipment, doesn't necessarily need to be routine testing like you would for oil samples, but doing it every now and again when you suspect there's an issue are good practices as well. Diesel fuel sampling kits. So a couple golden rules in North America, but more specifically Canada. It is a government requirement to ship diesel fuel samples in metal containers. We also typically need more sample volume for routine diesel fuel analysis than we do for oil or coolant or anything like that. So these 1 liter metal containers is perfect. Just have a couple stored on site and use them as needed. Proper sampling techniques also apply, right? So you want the fuel that you're sampling to be an accurate representation. So I go into more detail on the full webinar on our website, but how are you sampling your diesel fuel? Are there sampling valves? Is it pumps? Are you using baking bombs or fuel sample thieves and sticking it down the fill cap on your reservoirs, or are you just draining? And if you're draining, are you getting more water than fuel, etc.? So that's something else to keep in mind. But basically, the goal here is to try and get everyone thinking of their diesel fuel monitoring program. Are we doing any sampling? Am I aware of all of the distribution points in my diesel fuel network? Do I know of the areas with highest potential for contamination, whether it be solid, particulate, or water, or fuel mixing even, or anything like that? So if you're starting from scratch, the first good practice is try and visualize where all your distribution points are, either major or minor in your diesel fuel network. Start taking some samples to identify where things are clean, where they get dirty, how long are they dirty throughout the entire distribution network. And then start to consider the reasons why it's dirty or wet or whatever, right? Do I need to modify my storage time? So are my tanks too big for my actual consumption rates? What type of filtration process do I have in place? Do I have any filtration in my bulk tanks at all, or am I relying on my equipment fuel filter system to do all the work? You can even introduce some polishing units and skids that will filter and separate water as a kidney loop in your bulk tanks. All right, and again, when I was talking about equipment OEM service guidelines and stuff like that for your fuel, do we need to modify RPMs, or do we need to apply better filters or something? What is the condition of the fuel based on our current PMs in terms of contamination prevention and stuff like that? So again, if you do want to audit yourself, the current state of diesel fuel quality and cleanliness, or if you want to start implementing some of these improvement projects, it's a good idea to have a lab support your efforts, give you actual data. Is it cleaner? Is it drier? What's my blend? What are my actual blends while in storage and stuff like that? So to finish everything off, even though diesel fuel is consumed a lot quicker than lubricants and greases, cleanliness and quality still matter. Most engine failures related to diesel fuel are going to be directly related to contamination. Fluid Life, other oil analysis labs can provide diesel fuel analysis in terms of cleanliness and quality. And improving diesel fuel cleanliness across your distribution network is not going to hurt anything. It's probably going to give you a pretty decent ROI in terms of equipment fuel health, or primarily diesel engine fuel health, and prolong the life of filters and water separators and stuff like that. So yeah, that's my presentation. We got maybe a minute or two for questions or comments. Anyone have any questions on anything that we talked about? Okay, well, perfect. I guess before we sign off, I just want to thank everyone again for joining our webinar. I hope that you found this informative. If you have any questions after the fact, please feel free to contact me directly, and also visit our website. We have a bunch more webinars available there. We have a full resource center with white paper documents, general guidelines on diesel fuel health, oil analysis health, a whole bunch of stuff. So thank you very much, and have a great rest of your day.